So number 5, let f be the function given by f of x equals natural log of x over x for all x greater than 0. The derivative of f is given by f prime, so it even gave you f prime. You could have found the derivative without it giving it to you, couldn't you? Using the quotient rule, okay. Part A, write an equation for the line tangent to the graph. That's easy. Why are everything so easy? A, we want a tangent line, so what are the two things we need? We need f prime of what? E squared, right? Now, it gave you f prime, so that's nice. So what's that going to say? 1 minus natural log of e squared over e squared squared.
Wait, isn't natural log e squared just 2?
What did you ask me, Dakota?
Where did you just put that from?
In the
Plug e squared into...
yeah, I plugged e squared into f prime. So that simplifies to, I'm going to rewrite it like this. 1 minus 2 natural log of e over e to the 4th. Remember, on log functions, the exponent can go to the front, right? And then natural log of e is just 1, so 1 minus 2 over e to the 4th, which is negative 1 over e to the 4th. So that's my slope. And it's a constant, isn't it? That's a number, right? Okay, so nothing weird about that. What's the other thing I need for a tangent line? So I got to plug in e squared to f. So that's going to say the natural log of e squared over e squared, which is 2 natural log of e over e squared, which is 2 over e squared. So what's my tangent line? Equals negative 1 over e to the 4th times x minus e squared. Now, does it ask you for the form? Does it need to be in a particular form? Does it ask you to linearize? No, so you could leave it like this. If it asked you to linearize, what would you have to do? Get y by itself and then just call it L of x. Right? If it asked you to linearize, but it didn't, so we're good with that. 2 points. So you get, well, 1 point for the tangent line and probably 1 point for f prime of e squared. Yeah. Part B. Find the x-coordinates of the critical points of f. Do you remember critical points? Are critical points necessarily extrema? No. Are extrema necessarily critical points? Yes. Okay. B, we want critical points. So how do I find critical points? What are the three types? When f prime does not exist, when f prime equals 0, and at endpoints. Okay? Are there endpoints? No. How do you know? Well, there is a domain. It says for all x greater than 0. So is 0 an endpoint? No, in a sense, because it says x is strictly greater than 0. Right? So the first critical point is when f prime does not exist. When does f prime not exist? At 0, but that's outside of the domain that I'm considering, right? Okay. So the next critical point is when we do what? Set f prime equal to 0. What was the question? No, because it's outside the domain. Yeah, but you wouldn't indicate it as a critical point. In other words, you can't have an extrema at that point. But it is a good idea to put on your graph. All right, so when does this happen? What do I do? Cross multiply, so you end up with 0 equals 1 minus natural log of x. Now what? Add, so you get natural log of x equals 1. And then we rewrite this as an exponential function. So what would that say? E to the 1 equals x. So x equals E. Okay. So that says find the x coordinates of the critical points. There's the only critical point. Determine whether this point is a relative min, a relative max, or neither. So, what are we going to do? Draw a number line. So this is when f prime is equal to 0. Is that what we call f prime? Okay. And yeah, maybe indicate 0. So you know you're not picking numbers that are negative. And if you pick numbers that are negative anyways, that doesn't make sense because x can't be negative in natural log. So what number do you want to pick here? 1 for sure. Plug it into what? F prime. So since f prime is 1 minus natural log of x over x, we'll plug in f prime of 1 and get 1 minus the natural log of 1 over 1. What's natural log of 1? E raised to what power gives you 1? 0. So it's going to be 1 minus 0, or just 1, which is positive. Okay. What's a number I want to pick that's greater than E? That might be true, but for some of you, we had a problem very similar to this on a quiz. What number did I pick that was greater than E? E squared. Why did I pick E squared? Because I already found f prime of E squared, didn't I? What was the sign of f prime of E squared? Negative. Okay, so we would say f has a relative max when x equals E, since what? F prime changes signs from positive to negative when x equals E. Is that all it wanted? Yeah. So it says find the critical points. You get 1 point for the critical point. Determine whether it's a relative min, max, or neither. So you get 1 point for saying it's a relative max. And then you get 1 point for the correct justification. Okay. What happens if this was negative and positive? Relative minimum. What happens if it was negative and negative? Neither. If it was positive and positive? Neither. Okay? Are we good with that? 5 minutes? Okay. So, where is that? Can I get rid of this? Okay. I think we don't need any more of this. All right, C. The graph of the function f has exactly 1 point of inflection. Find the x-coordinate of this point. How do you find points of inflection? When f double prime changes signs. So we've got to find the second derivative. So we have the first derivative. We're going to use what? Quotient rule. So what's the derivative of the top? Negative 1 over x times the bottom minus, let me do this, sorry, because I don't think the camera can see it, that's why. Well, I wouldn't want you to go home and try and study and then everything that we're saying is not there. So negative 1 over x times x squared minus 2x times 1 minus natural log of x all over x squared squared. I'll write it down just for the heck of it. So f double prime of x equals, simplify, the top becomes negative x, and I'll distribute this, so it'll be minus 2x plus 2x natural log of x, okay, all over x to the fourth. You guys okay with this? Okay, keep going. Got to keep simplifying. Simplifying is better than not. So, yeah, we can factor out an x, so we end up with x times negative 1 minus 2 plus 2 natural log of x, all over x to the fourth. Keep going. All this math here. So what's this simplified to? Negative 3 plus 2 natural log of x over x to the third. All right. Where are our not critical points, or kind of critical points? When x equals 0, but that's outside the domain, right? And when we're talking about points of inflection, we never consider the endpoints anyways. So we're going to set this equal to 0. Solve for x. What do? Add 3, so 3 equals 2 natural log of x. Divide by 2, so you get 3. Wait a minute. Yeah, 3 over 2 equals natural log of x. We've got to solve for x now. E to the 3 halves equals x. You guys okay with this? Does that mean that's a point of inflection? No. What do we have to do? We have to see if it changes sign. So e to the 3 halves, what's a number to the left of that? You can't plug in 0 because that's 1. Okay. So if I plug in f double prime of 1, we get negative 3 plus 2 natural log of 1 over 1 cubed. What's natural log of 1? 0. So that's going to be, all this is 0. So we get negative 3 over 1, which is negative 3. So it's negative over there. You guys okay with that? What's a number bigger than e to the 3 halves? E squared. Just like the last time. E squared equals negative 3 plus 2 natural log of e squared all over e to the 6th. You guys okay with this? So negative 3, what do I do here? Bring the 2 in front, so you get plus 4 natural log of e. What's natural log of e? 1. So negative 3 plus 4 times 1 is 1 over e to the first, or e. What do I get e to the first? E to the 6th, right? It doesn't matter, it's positive.
But okay, I have a question.
Well, hold on, let me finish it.
Okay.
Is there a point of inflection then? So, f has a point of inflection. It doesn't say explain. When x equals e to the 3 halves. I would justify it no matter what. What would the justification be? Since f double prime changes signs. Well, say it again. I'm thinking 1 point for the second derivative. 1 point for the answer, and 1 point for probably setting f double prime equal to 0. I'll have to look for sure, but so find the limit as x approaches 0 from the positive side of f of x. So what do you do first? Try substituting f of 0 maybe? That's not going to work, is it? Natural log of 0 over 0. What's the natural log of 0? E to the something equals 0. It's undefined. So it's undefined. If it's undefined, it's probably infinity. What's that? Well, the function does not exist. True. But we're looking for the limit. So it's a logical thing. We're taking the limit. So I'm going to write it like this. The limit as x approaches 0 from the right of, what is the function? Natural log of x over x. Could be rewritten as the limit as x approaches 0 from the right of the natural log of x. over the limit as x approaches 0 on the right of x. So that would be this limit as x gets really close to 0, what's happening to the natural log of x? What's the graph of x look like? Or natural log of x look like? It's like this. So as x gets really close to 0, what's f of x getting close to? So negative infinity on top. As x gets really close to 0 there, you get 0, right? So, but 0 from the positive side. So these don't contradict each other. Infinity over infinity contradicts. But as the number on top gets really big of any fraction, if I say 1,000 over 1, 10,000 over 1, 100,000, whatever, what are we getting close to on top? We're getting close to infinity, right? So, but if the bottom number gets smaller and smaller and smaller, so if we say 1 over 0.00001, what's the whole answer getting close to? Infinity again, right? So both of these agree with each other. So negative infinity over infinity, the limit would be negative infinity. So that's just kind of a logical understanding of what's going on with it. So 1 point for the right answer.